Now, chapter 9 is about reasoning and proof. We are going to study here the methods of proof of some statements. Okay, we'll be given a statement, we'll be given theorem, we are going to prove it. So in your book, actually, they went with many details. They divide into many subsections. So we're not going to cover all of them. I will just go with the specific one which you will need. So the first today we will start with the part B and C. I'll just to combine them. This type of proof you already know. Then we are going to see the this proof by counterexample, proof by contrapositive, and by contradiction. And later on, when we finish this chapter, in chapter number 10, we are going to see proof by induction. That one is also very important. So let's get started. What proof is? For example, we'll be given statement and we are going to reason it. We will go with some statements to prove it, whether it's correct or not. For example, let's say from your book, I just took this statement. If A and B are real numbers, then A smaller than B implies that A squared smaller than B squared. At first, it seems correct. There is no problem, but it says for all numbers, all real numbers. For example, it's correct when I choose 1 and 2. It's small, and it implies that this one is also smaller. 1 squared smaller than 2 squared. But if I go with the -2 and 1, as it says to real numbers, it's correct. But when I take the square, it will be 4. And it's not smaller than 1, it's bigger than 1. So this statement is incorrect. So what did I do? I gave counterexample, so I disproved it. So there are different methods of proving. So this one, it's what we are going to see in this chapter. So also in your book, the definition is given. What's a proof? You will have mathematical statement, argument, and we are going to, we start with the assumption also. With the assumptions like here, real number, then A smaller implies that this one is assumption. If this one is correct, then we are going to see whether this one is correct or not. So we'll go with this some sequence of mathematical steps. We'll go with the reasoning statements, and we'll come up to the conclusion whether it's correct or not. So let's start with the new book. It goes with part B and C. I took the example from different places. So these proof by deduction, or in some books they also call direct proof. This type of proof you have already seen it. So you just need to prove the left-hand side equals to the right-hand side. So here we have the statement. As you can see, the left-hand side there is this one statement, polynomial statement, and on the right also there is. So let's see whether they are equal or not. Left-hand side, what will be if you open the brackets? It will be n squared plus 8n plus 16 minus 3n minus 4, right? If you simplify it, it will be n squared plus 5n plus 12. And the right-hand side, let's see the right-hand side also. If we open it, n squared plus 5n plus 4 plus 8. So as you can see, n squared plus 5n plus 12. The left-hand side equals to the right-hand side. So this one is one of the methods of the proving. This part you have already seen. So I will just naming it. Or for example, if you remember from trigonometry, let me give just a simple example. Tangent x times cotangent x equals to 1. So we need to show that or prove this statement. So what do we know? We know that sine is what? The right-hand side is just 1. So I need to just simplify the left-hand side by giving reasons. We know that tangent is sine divided by cos, and the cotangent is cosine divided by sine, which comes from the definition of the trigonometric ratio. So from here we can see that the left-hand side is also equals to 1. So 1 equals to 1. This statement is correct. So mostly you will say prove that or show that in these type of questions. Let's see some different types of problems. Again, show that this statement equals to left-hand side equals right-hand side. So it has the same idea. You just need to open the brackets and see, as you can see, right-hand side is already simplified. So you just simplify the left-hand side and check whether it gives you the same statement. If it doesn't, that means we cannot show it. So most of the problems will be with that. It's possible. You just need to simplify it. Let me just skip it. I will leave it to you. This problem. Show that the sum of an odd and even positive integers is always odd. The sum of two even numbers is always even. The sum of two odd numbers is always even. So if you go prove by just example, it won't be enough. It's not proving. For example, it says the sum of an odd and even positive integer. So you say, okay, 3 plus 4 is 7 odd. Okay, if you say I take another number 5 plus 8, 13 odd, it's not proving. You're just giving examples. You cannot prove by examples. So we need to follow some mathematical statements. So just need to remember, how do we show even and odd numbers in general, like a formula? Even numbers, know that it can be shown as 2 times n. N is a natural number here, right? Or n can be integer. So 2n. All even numbers can be shown as a 2n for any n. And odd numbers, if you don't know it now, you have to know it. If you see this type of problems, you have to go always like, and odd numbers are, how do we show them? 2n plus 1, or let's use different letters. It can be 2k plus 1. Okay, so for any k, the odd numbers are usually shown like this. So if we go, we can use the same letters because even and odd numbers. So if we go, let's say, if I list the numbers, you can easily see it. 4, 5, 6 integers. Also, if you go to the negativity, you will see that in general we show even numbers as 2n and odd numbers as 2n plus 1. Now let's prove the first statement. It says the sum of an odd and even positive integer is always odd. So 2n plus 2n plus 1 will be equal to 4n plus 1, right? And this one can be written 2 times 2n plus 1. So from here we can see that this one, if I call it some differently, let me call it k, it will be 2k plus 1. So it gives me odd number. If I had used k also, you will get the same result. Plus 2k plus 1, what will you get? You will get 2n plus k plus 1. So from here we can see that it has this form in general. Okay, part B. The sum of 2 even numbers is always even, so I don't believe it. Okay, let me call one even number 2n and the other one 2m. For any n and m can be any integer. So here general I can write n plus m. So n plus m, if I call it something different, let it be t, it will be 2t. So as you can see, it has the form of the even number. So you can say, generalize it, it's an even number. And the last one, I guess it's straightforward. The sum of 2 odd numbers is always even. So if I have 2n plus 1 plus 2k plus 1, I'm just adding 2 general formulas of the odd numbers. What we will get? We will get 2n plus k plus 2, and which can be written as 2n plus k plus 1. So here, whatever it is, I can simplify it. I can write s, so it will be 2s. At the end, it will have the form of the even numbers, 2s, for any number. So s can be any number, and k can be any number. So this is how we need to prove these type of questions.